Welcome to CS171, Section 6. Up to now we've been building standalone graphs in D3. This week we're going to learn to connect graphs together to form interactive linked views. First, let's talk about lines. This is how we make a line in D3, if you remember. Using the line element, this is how we make a line in SVG, using the line element and then an x1, y1, x2, y2 attribute that we specify, and that would give us a line like the one we're seeing right here. But in fact, there's another way to draw lines, and that's with the path element. The path element uses a single attribute called a D attribute, and inside has a string that defines the properties of this path. I'm introducing the path today because the path element is very powerful. Not only can it help us do things we can already do in SVG, like lines, it enables us to do enables whole new categories of things we can draw, like this Bezier curve here. This D attribute, this long D attribute, defines all the properties and parameters of the Bezier curve here, and we can draw it like that. We can draw very complicated polygons and many types of things with path. The good news is we don't have to understand this D attribute, the innards of how this works. Because every time we'll be using the path element, we'll be programmatically generating it. Let's look at an example. Here I have some code that we'll be walking through today, and let's look at the area chart that's there. If we inspect this area chart, you'll notice that the area is a path element with a single D attribute. And that D attribute is huge, it's gigantic. I'm scrolling down here, and there it is. It's enormous. And this D element, this D attribute was programmatically generated by D3 for us. So let's talk about this code right here. This code is available at start/index.html. And this is a visualization of Somerville 311 call data. So this is Somerville, the city of Somerville's municipal helpline. And the city makes a data set about the types of calls and about all the calls that they receive, publicly available. And this is a visualization of that. The source data is included in this repository, as well as a little JavaScript script that filters and cleans it up and puts it in a format that we can consume. I've selected data for 2012. Let's look at index.html. This is the file we were looking at, and the first thing that might strike you when you open this is how little JavaScript there is. This is all the JavaScript there is in the file, and most of it is just consumed with getting the data and plumbing like that. In fact, everything about the visualization we're seeing is this one line of code. Let's comment at it. Oop, not quite. And there it is. This one line produces the entire visualization. And this shows what we'll be talking about in the rest of today's section. Everything about this visualization is encapsulated in this volume viz object. Everything about this visualization is hidden in a separate file in JS volumeviz.js, where we define this volume viz object. All the code regarding this is in here, and it is encapsulated in here. And today we'll be exploring this idea further. We'll be talking a lot about structure and how to separate multiple visualization, how to have them interact with each other. In addition to this volume viz visualization, we also have a type viz visualization. So in our data we have in the data file we have data about the types of calls, in addition to the volume of calls. So let's, and we already have some infrastructure and some D3 code for producing that inside the typeviz object. So let's add a typeviz visualization. Like this. And if we go back to the browser and refresh, you'll see that we now have we have a bar chart at the bottom. That's the type viz. You can see that, for example, the most common call is, by far the most common call, as a matter of fact, is TV monitor trash pickup, followed by school buildings. I don't know what that is. Potholes and miscellaneous is apparently quite common. These are only the top 20 of a very long tail of types. So let's look at how this is being created, how this bar chart is being created inside typeviz. Well, first let's realize that so I mentioned that everything inside typeviz was encapsulated, was hidden inside the typeviz object. As a matter of fact, we can create two typevizes. If we do this, see that we have two identical visualizations at the bottom. We can, since everything is snuck and hidden and encapsulated inside this object, we can instantiate many of them without them interacting with each other in some unexpected way. So I remove that second redundant visualization, and here we are. Let's look at the typeviz code. So the code for typeviz is in js/typeviz.js, and this is it. This is the code. Let's walk through it briefly. So at the beginning here, in what's known as the constructor, we define some basic constants. Things like, and these are constants that are specific to the visualization. So things like margin, width, height, and so on. Then we have initviz. Initviz sets up basic infrastructure for the visualization. Things like adding the SVG element that we're going to stick our visualization in, setting up axes and scales and things of that nature. This is a one-time initialization for the visualization. After that, the other big part of the visualization is wrangle data. Wrangle data takes in the data and filters it and cleans it up and changes it in ways that the visualization can then consume. And after wrangle data is update viz. Update viz actually draws a visualization. It uses the data that was just wrangled and does something like updating the scales and does the actual data join to add bars and add the axes and the text labels and so on. Update viz does the actual drawing of the visualization. So let's review these three parts: initviz, wrangle data, and update viz. Initviz is a one-time operation, and wrangle data and update viz both happen every time we want to update the visualization. So if we want to filter the data, we'd have to call wrangle data and update viz to restore that visual, to redraw the visualization. Let's walk through this in a more complete way. As a matter of fact, we're gonna open, instead of start, we're gonna look at debug/index.html, which is the exact same code, except they have these special debugger statements. We'll see in a minute what those do. So I just opened debug/index.html. And you notice we're in this weird state now. The main view here is grayed out and says paused in debugger, and that line where we have the special statement is highlighted. This is a debugger statement or a breakpoint. What has happened is we've instructed the browser to stop. Once it gets at a specific point where the statement is, to pause, to stop, so that we can understand the state of what the programming, the computation, what the program is trying to do at that point. And I added many of these statements inside the debug files, so we'll be able to walk through the code. So here we are inside the debugger. We've drawn the volume visualization, the area chart visualization, and we're just about to create the type visualization, the bar chart. We haven't done it yet. We're right off the cliff and right about to do it. If we click this play button, we'll go inside that and see what happens. So there you go. I just clicked that, and here we are. We're inside what we were discussing right before, the constructor. And this is where we're defining constants. something that's very useful about this debugger statement is that we can inspect the state of variables. So you'll notice we're using this here, and that might be something you're not familiar with. We'll come back to that in a little while. But the thing to realize is that variables that are defined like this, that are called this dot something, are variables that are going to be accessible everywhere inside the type, inside the object. So anywhere inside this file, essentially, we'll be able to access to these variables. So here we are, we're defining margin, width, and height on this. And this debugger, in this pane right here called scope variables, enables us to look at those variables. So if we open this right here, you'll see that we can see those variables being defined, like height being 350, width being 730, margin, and so on. And you'll see that our source data is here. This is the actual data, an array, each of which has inside of them an array with the calls, information about calls, things like address and date, and so on. I'll call your attention as well to display data, which we initialize to be an empty array here, and it is indeed an empty array. And there we are. So we've just set up basic things about the visualization, and we're about to actually initialize it through initviz. Let's look at initviz. Let's play. And here we are. Here we're right inside initviz. Remember when we were looking at that inside the code. So the first thing we do is we add this SVG and the margins and deal with the margins. And in fact, if we look at the HTML with a DOM, we'll see that we indeed now have this SVG element. It's there. The visualization has been initialized, or is in the process of initializing since we're in the middle of it. Here we are. And we'll see that inside of this, we now have a lot more stuff like X and Y, which are scales and axes, and just a lot more things that are accessible to us. Display data is still an array of 0. So now we're in the middle of initviz, and initviz is about to call the wrangle data. Wrangle data is going to do its job of filtering the data and putting it in a good format. So let's play that and see what happens. So wrangle data is run, and now we're at the step right after that. And you'll see that display data now has 20 things in it. It has an array of 20 elements that are the top 20 elements by count. So the count and the type name. So wrangle data has taken data and did its thing on it to transform it in a format that we can understand inside display data. And display data is what the visualization will see. What the visualization will be bound to the elements when the visualization step happens. As a matter of fact, we're about to go there. We're about to call update viz. That's actually going to take this data and visualize it. Let's see it. Let's click play. And here we are. We're in the middle of update viz. And here we do things like setting the domain, and here we're setting up the axes. So you see we're right in the middle of it. The axes is there, but the bars themselves are not quite there yet. And the data join for the bars is about to happen here, as well as the labels and so on. Let's play till the end. Boom! There we are. That's our masterpiece. So to summarize, we initialize the visualization. That's initviz. We got the data. That's wrangle data. And we created the visualization with that data. That's update viz. Great. Let's look at interactive. The interactive files. These have the debug statement removed so that we can make some modifications to the code. This is interactive. This is the interactive file. In particular, let's look at typeviz. This is our typeviz code. So what if we wanted to add colors to the bars? We wanted these bars to encode, to have them more differentiable with color. We already know how to do that. We just need a color scale. So let's do exactly that. So let's start in initviz. So right here we're defining X and Y scales. Right here we're going to define a color scale like so. That just initializes it. We don't need to do anything in wrangle data because the scale doesn't affect the data. And in update viz, like we do right here, we need to make sure to update the domain of the color scale like this. And now we have a color scale. And like we know how to do, we'll go back to our bars here. Our bars are right here, and we could just set a style, fill, and use our color scale like this, exactly like we would. Let's refresh. And oh no, we get an error right here on a line we just added. Uncaught type error. Undefined is not a function. It seems that it doesn't know of color on this. It's saying, I don't know about color. But right here, we are defining color. I mean, we're using color right here and it knows about it on this. And it's supposed to be there. As a matter of fact, if we went somewhere outside and just did console.log this.color and gave any type, like pothole, that. We do have a color. It seems like it works there, and that's really weird. Let's add debugger statements like this, and here as well. So it's going to stop twice. The first time it stops, here we are. Let's look at this and color, and we have something there. Color exists, and it's a function. That sounds good. Seems all fine. Let's run through it. And wow, this is completely different. This variable called this is rect here for some reason. How does that make sense? This has been changed to something completely separate. And this brings us to a very important point in JavaScript. The variable this is a special variable. The variable this indicates the context we're in. So when we're here, we're in the context of the object, this type viz object. However, when we jump inside any inner function, the context changes. Functions change the context of the visualization, of the execution. And the value of this changes to something completely different. So we can't call this .color because we don't have a reference to the outer object. We don't have a reference to this. So what we could do is just have two names for this. Say we could call it var, we could call it me like this. And then inside of here, you could call me like this. So that the inner this doesn't overwrite the outer this, because we want the outer this, and it's getting shadowed by the inner this of the function. And if we do this, refresh, there we go, we have color. Nice. So it turns out that this is such a common pattern that the JavaScript world has a convention for this. And that's using that. So it's very common. You'll see this you'll see this very often, where the first line is var that equals this, so that we have a reference to that. So instead of me, we called ours me, but that is calling it that as the convention, like this. And this would work as well. So the lesson here is if you're using this inside of a function, a nested function, and things don't appear to be working right, you're almost certainly using a different this, and you want to be using that. What we really want to do is explore the interaction between these two views. We want to be able to understand, say, of the types are complaints about potholes, say, more common over the winter, over the summer, for example, as one would expect, Similarly, for tree trimmings, one would expect there's a relationship between the type and the time, or maybe school buildings are very common during this. School building complaints are very common during the school year or something. We want to understand how these two dimensions of the data interact. So let's do exactly that. Let's have some functionality so that when these bars are clicked, the rest of the visualization updates. Let's link our views. The first thing we want to do is to detect that a bar was clicked. We know how to do that. But in the enter set, since this ought to only apply to new bars, like this, there we go. We should be able to detect that something was clicked, that the bar was clicked. Let's see to make sure. There you go. Hey there, console 2. So let's remember our 3 steps: our init viz, wrangle data, and update viz steps. On click of one view, we need to filter the other view's data and update its visualization. So when one of our bars is clicked, what we want to do is on the other object, on volume viz, we want to be able to wrangle its data, call wrangle data, and update viz. We want to change its data and update its visualization, but on somebody else, on another object that's outside of us. Let's look at volume viz. This is volume viz, like we've seen before. And we mentioned we wanted to wrangle data and update the visualization. As it turns out, volume viz has a function for doing those two things already. So volume viz knows how to filter itself and update its visualization. All we need to do is call onSelectionChange on volume viz. What we really want to do is something like this. If we try it out here, like this, nice. Our visualization has updated filter for potholes. Now we've just did this manually. That's not what we want. But the volume visualization knows how to filter itself and redraw itself for filtering for a particular type. All we need to do is connect those parts together. We need to connect the bar chart with the area visualization in some way. We need probably the plumbing between those two together. What we could do is something like, let's just copy this right here. This line, what we could do is something like this, and then just change this to be dynamic. Change the argument to be dynamic. But the problem here is that this is very inflexible. You might imagine a situation where there are many of these visualizations. Say there's 10 of these views on a page, and they all interact with each other in some complicated way. And every one of them has to keep track of all the other ones. So that if you have 10 of these views on a page, and then you have to add an 11th one, you need to change each of the 10 visualizations so that it be aware of this other one you're just adding. And that's really clunky. What we really want is that all these views interact with each other through a central intermediary. The architecture we want here is that this view notifies some central command that it wants the entire state of the page to change, and it makes the decision of how to dispatch that information out to the subviews to redraw the page. We need a central intermediary, and we have that through index.html. Index.html should be the place that knows about all the visualization, and it should do the work of filtering the views when required. So to do this, we'll be using JavaScript events. Events allow us to broadcast that something happened, and parties that are interested can listen in. So really, an event is like yelling out something. So an event is just, typeface could just yell out something in the air, and whoever's interested can listen and do something about that. For example, at the beginning of a class, I could yell out select section start as an event called section start, and that would indicate to the people listening, the audience of the section, that you should change your behavior and start listening. Or maybe you, when you raise your hand, the analogy would be that you're triggering a question asked event. And by doing that, you're just kind of yelling that out to the class, notifying the class that something has happened, and I would be paying attention to that and changing my behavior in relation to that. So what we want to do is we want our type visualization here to trigger an event, to just yell out that something happened, and then the other part of our code to pay attention to that and do something about it. So this is the syntax for yelling out, for triggering an event. We'll call our event selection change. We can call it whatever we want, and we'll pass it a type like this. And if we refresh and try that, when we click on a bar, absolutely nothing happens. The best kind of rewarding. Nothing happens whatsoever because our type visualization, our object here, is yelling out selection and change. Every time we click, it's yelling out selection change. But there's nobody there to listen. Nobody cares that it's yelling that, so nothing happens. Let's change that. So to listen to events, we'll listen to the event here. This is the syntax for listening to the event. We pass the event name like this. So, looking at this code just briefly, this is just the syntax for triggering an event. This is the syntax for listening to it. This $ might seem a bit foreign to you. That's jQuery. This is a syntax that makes it easier to interact with objects, with events. And let's refresh. Oh. Let's, just a quick error right here. Like this. And here we are. So when we're gonna click this bar, the type visualization is gonna trigger an event called selection change, and now index.html should be listening to that and logging it to the console. There you go. Nice. Miscellaneous. Now we've decided to just log the type, which is passed as an argument to the event, and there we are. So we have a messaging interface from this object, this type viz, to the global state of the page. And at this point, all we need to do is use what we had before on selection change and pass in that type. Let's try it now. This is beautiful. Look at this. This is nice. So we had a hypothesis about potholes. Interesting. They don't seem that overly common over the summer. They seem actually quite common in the spring, which is interesting. Certainly, possibly sidewalk repairs. Oh, even them they're common in the summer, but also common in the fall. Interestingly, tree I would imagine are pretty common over the summer. School buildings, I'm not sure what that is, but that does seem somewhat more popular during the school year. This enables exploration of our data through these two dimensions, and it's a very powerful idea. Great. So now let's look at the brushing files. This is just a checkpoint of our work up to date. Up to now, you're welcome to look at. So our bar chart encodes categorical information. We can filter the visualization with this categorical information. But we want to be able to go in the opposite direction as well, really. We want to be able to filter by a specific time range and see the distribution of types associated with that time range. Our area chart encodes time index data, and we should use it to filter for time from other views. Now, maybe we're interested in this area around September here. A good way to do that is through brushing. Let's look at an example here. This is an unrelated D3 brushing example, but this interaction right here of being able to select an area chart, scrub around, expanding edges out, deselect from the outside, and so on. And then continue to explore like this. D3 provides some basic, already built-in infrastructure for selecting those from an area chart and an x-axis, so we'll implement that. The first thing we want to do is just add the selector to our volume visualization. So we'll go in our volume viz file. For now, we're not touching the other visualization yet. We're just concerned with dealing with ourselves. And we'll initialize right here. We're going to set up a brush, and this is how our brush is set up. Like so. And we need to add this placeholder G that's going to contain the brush in the future. This is just how D3 brushing works. Okay? So brushing doesn't affect our data, so we don't have to change Wrangle data. Wrangle data is fine. Brushing is going to affect the other view's data, but not ours. So no need to touch Wrangle data. But it is going to affect update viz because we need to make sure to redraw the selection rectangle. In particular, the first thing is we need to pass in the X scale to brush, because brush needs to know of the scale. And we need to find that placeholder G we had before. Just call it like this. And add a rect to it if necessary. Like so. This is just how brushing works in D3. This is, just the setup required. And if we refresh like this, nothing really changes, but now we have this selection ability. Now, this is great. D3 gives us this almost for free. It's very easy to add. So we can add these interactions, select the edges, deselect, and so on. Of course, nothing happens. We haven't connected. All we're doing now is adding these graphical elements, but we haven't connected that selection to the other views on the page and made them aware of the filtering. The way we do that is very similar to how we did our on-click. Going back to the initial setup that we had right here, we would just add our brush on brush event like this. And we'll go through this statement very briefly. So this statement here, brush.extent, gives us the area that was selected. Gives us information about exactly what was selected. If we refresh and open our console, since we're logging there, as we select areas, this brush.extent statement gives us information. Gives us a two-element array of the minimum value and the maximum value that was selected. So you'll notice if I change the minimum, only the minimum changes but not the maximum. If I move around like this, both values change and so on. So we could use that information, these two time values, to filter the rest of the visualization. You'll notice though, if we deselect this, these values are not correct. They're the two same values. So we also need to listen to that brush, that empty, to make sure we properly account for the brush being empty. Like this. So it's always false, and if we unclick, then it becomes true. So thinking about this at a high level, we now have inside the code here, we have information about the particular area that was selected by a brush. And as every time the selection changes, this code re-executes, and somehow we need to make the rest of the views aware that the selection and the filter was changed. We just need to connect the pieces together. We won't do that today. But just thinking about how we would do that, we do it very similar to how we did with click. We just need to trigger a selection change event here, and then pass in these two values, now, the minimum and the maximum, and have the central intermediary, index.html, listen to that selection change like it already does, and dispatch that to typeviz with those two values calling on selection change. So walking through that again, inside of here, every time this is called, we trigger an event that would connect us to the central intermediary, using and passing these two values that are the minimum and maximum, using that information in the central intermediary to pass it on to the type visualization to let it know to filter itself based on these two values. And that is section 6. The final code that we've produced is available in the final folder, and that's a checkpoint of our current work up to now. And with that, see you next week.